Hey everyone, so this is NapFi. Every DeFi balance is public. When you deposit into a protocol, anyone can see your position, right? So NapFi solves three problems here. The first is privacy. So your balance is stored as a Zama FHE ciphertext on Sepolia, so nobody can read it, not even us. And second, verifiable agents. Every automated deposit posts an ERC8004 receipts on chain. And the third is native automation. So let's get started by connecting our wallet here via Google. And it'll take some time. Yeah, so our wallet has been connected, and let's configure our agent. I'm setting a saving goal for 10 USDC weekly, and the yield is enabled. And behind the scenes, the backend pins agent metadata to IPFS and mints a ERC8004 identity. The dashboard shows the agent ID, that's ERC8004 token minted, and the vault address points to the NapFi Uniswap vault contract. And the balance card shows the encrypted balance by the Zama FHE unit 64 ciphertext. So only the users can decrypt it. The Zama related SDK calls the vault get balance handler and verifies the user ACL permission and returns the clearest big integer. So this number is never stored in plaintext on chain. Your vault balance decrypted using Zama FHE, the contract stores this as an encrypted E unit 64. And the LP position shows the total liquidity in the Uniswap v3 USDC, which I'm going to show now, and the vault holds the position NFT and tracks your shares. So it's basically dual accounting, where the plaintext shares for the Uniswap math and the encrypted balance for the confidential UX by the FHE. The users earn LP fees, but their individual balance stay encrypted in the vault contract. So this is the yield part. Deposit goes to the pool and the fee accumulate, and the vault tracks everything with the Zama FHE ciphertext. This terminal shows the Flow Cadence transaction. The first saves the agent scheduler handler resource to the Flow account. This resource completely implemented by the transaction handle interface. And the second, which is the scheduled deposit, which calls the transaction scheduler with a 60-second delay. The network will auto-execute this at a scheduled time. And let's view it in the block explorer. And here are the transactions which has been conserved on chain. When the time arrives, the flow emits the deposit trigger event, and that's what it happened here in our terminal by the flow scheduler. So now that the deposit triggered with the user Sepolia address and the USDC amount, the server enqueues a pending deposit, where the dashboard polls for this and prompt the user to sign. And let's get back to the terminal. Now the vault contract receives the USDC and encrypts the amount using Zama FHE and adds it to the user's encrypted balance. So now the deposit has been completed. The Sepolia transaction has been confirmed on chain here in Etherscan Explorer. The encrypted balance is updated on chain, and everything is worked as planned. And we can see the address, and we can see that it approved the ERC20 token for the transfer to this particular account. And we can view the changes in our dashboard as well. So this is Zama version 9. All balance math happened on encrypted values. The clear text never touches the chain. Every log shows the encrypted handle. Anyone can see the transaction happen, but nobody can read the amount.